Lesson 50 is more on the chain rule because I really want you to move away from U substitution when you are differentiating, and I want you to start using chain rule. So today we're going to do a few more examples that are a little bit more complicated than what we did previously. So the first one is just a quick reminder of chain rule. So remember, you use chain rule when you have a function within a function, and we use it instead of U substitution. So you start and do the derivative of the outside. We know the derivative of cosine is negative sine. And what you're going to follow it with then is everything that follows your original function. So everything that's inside. And then once you do that, you take the derivative of this, which is 2x minus 3, and this right here is your answer. On the next one, oops, I forgot to write f of x equals on this. Next one, same way. You start with the outside. You take the derivative of natural log. Derivative of natural log is just 1 over itself. So we're going to follow that with a sine of 2x on the bottom. And then we're going to follow it with chain rules. So now we're on the inside. We're going to do the derivative of what's next. And what's next is sine. So the derivative of sine is cosine. And we're going to follow that with a 2x, which is what follows with this function. But we still have one more chain rule because we have to find the derivative of 2x, which is just 2. So this right here is your answer. If you wanted to write this as 2 cosine 2x all over sine of 2x, that is fine. But you do not have to write it like this. You can leave it like the above line. Okay, next one. Find the derivative of this function. So starting with the outside, tangent. The derivative of tangent is secant squared. And what we're following with is whatever was in the parentheses to begin with. Then we have chain rule to follow. Make sure you put the multiplication so that I can see, and the parentheses, so that I can see these are being multiplied by each other. And now we're going to do the derivative of this, which is going to be 15x to the 4th plus 1. And parentheses are necessary right there because that is a quantity that is being multiplied, and there is an addition inside there. All right, the next one gets a little bit more complicated because what we have here is we have quotient rule. And within quotient rule, we also have chain rule because on the top, this cosine is being squared. It's the same as writing it like this. And the reason I'm going to do that is because you're going to see where the chain rule is, and there's the outside function, that being squared. So starting with quotient rule, we start with the bottom term, so sine of x, times the derivative of the top. And here's where the chain rule comes in. We have to first do the squared. So we have 2, and we're following it with cosine of x, and now it's to the first power. And now chain rule says what is the derivative of cosine, and that right there is negative sine. And then we have minus the top, so now we have that cosine squared x times the derivative of the bottom, and the derivative of sine is cosine. And all of that is over the denominator being squared. Now, I'm going to highly recommend that when you have something that is squared, that you put your squared in between to keep it neat. If you want to pull this negative out in the front right here, you can, okay? You can, but you don't have to. What you cannot do is you cannot combine this sign with this sign because this sign is more than just a sign. It's a sign times 2 cosine of x. Notice there's no x on the sign. The only thing here you could simplify if you wanted to, and I'm not going to make you, is this right here because this is a cosine squared times a cosine of x. So you could write that as cosine to the 3rd power. But again, I'm not going to make you do that. You can leave your answer just like this because I want to make sure you know how to use chain rule within our quotient rule and all of that and do the calculus, and I'm not as concerned about the algebra portion of it. Here's another chain rule that also deals with product rule. So we have the first term right here times the derivative of the second. So the derivative of the second, we start with the outside term. So we have the 100 x minus 4 to the 99th power. And chain rule now says find the derivative of what's inside, and that just happens to be a 1. So technically, I wouldn't even have to put that there. Plus the second term times the derivative of the first, and starting with the outside. So I'm going to take the e, and we know e is just whatever to itself back. But then we have chain rule. Here's my inside function. So I have to follow it by a times a 4x. And again, don't worry about simplifying. You can leave your answer like that. You'll notice in the back of the book, they're going to take and factor this out of both terms. And they may even factor out one of those from both terms, or 99 of those. Don't worry about that. You can leave your answer like that. So some of your answers won't match with what they have in the book. Okay, this one gets a little bit tricky too, because we have chain rule within chain rule multiple times here. So starting with the outside function right here. When we do this, we have 6 times whatever's in parentheses. That hasn't changed, and that's going to be to the 5th power. And now when we move inside with the chain rule and find the derivative of this, we know the derivative of 1 is 0, so that's fine. But this cosine that's squared, remember, is the same as this. So we have chain rule within this as well, because we have first the squared, so we're going to have times 2 cosine x, and now it's to the 1st power. And then we have chain rule within this. We have to multiply by the derivative of cosine, which is the negative sine of x. And again, you can leave it like this. If you want to pull the negative out, you can, but as long as you have parentheses, you don't have to do that. And with that, your assignment is right here. You could submit to Schoology when you're done. Bye.